Hi there. This is video 29, some mixed practice for compound interest. And I notice this set of questions actually has answers in there for you, which is cool. You don't have to flip to the answer key to get them. So A, P, I, N. What annual rate of interest? Okay, so oops. We're looking for interest, compounded quarterly. If the initial investment is $3,035 after 5 years. Okay. So N, 5 years, times 4 is 20 time periods. My interest, I don't know. I'm going to do it the way I usually do. Because this part is going to remind me how I want to adjust my interest. And I'm starting with $3,000 and I'm ending with $3,500. Okay, so whoopsies. Let's get our formula. So 3,500 is equal to 3,000. 1 plus, do I know? No, that's the one I don't know. To the 20. Oh, it's got all kinds of cool stuff going on. All right, so we are trying to isolate the I. And I bet there's a master sheet that we probably should have done before this. I'll make sure it's done for you. Anyway, let's get rid of the 3,000. We need to isolate this part so we can divide by 3,000. We can always do that. So 3,500 divided by 3,000 is 1.16. All right, repeating. Is equal to 1 plus I to the 20th. Now we have to do that conversion, right? We got to get rid of this 20 exponent. So we're going to put the square brackets. I don't have to square brackets, but I like them. And we're going to do the reciprocal. 1 over. Same thing, right? Golden rule equations, whatever you do to one side, you have to do to the other. So I still have that 1.666666. Sorry, I have the number here. And I'm just going to do exponent, and then I'm going to use my bracket keys. 1 divided by 20. That's that little part. Oopsies, 20. Close my brackets and equals. And I get 1.007737. I don't know how many I need there, so I'm just going to write them all. Is 1 plus I. Subtract 1, subtract 1, subtract 1. So 0.007737 is equal to I. But, should get to, sorry, I'm a little excited. But that is the interest per quarter as a decimal. So in other words, my answer is over here. So if I want to get back to the interest per year, I need to multiply it by 4. And I need to multiply it by 100 because by 4 we'll get it per year, and by 100 we'll take it back to a decimal. So times 4 times 100, and that gives us 3.094 or 95. So we're just going to go 3%, which is pretty close. I'm not sure why that one is 0.96, because when I round mine, I get 0.95. I'm not going to stress too much about it. I'm just going to round it to 3%. Okay, so let's go through. I want to go back to here, show you those key punches. I'll show you two different ways you can do it. Okay, so what I did, I'm going to write it over here. I went 3,500 divided by 3,000. Put a box around that. And then I hit equals. Let's do it again. 3,500 divided by 3,000. And that gave me this number. Okay, remember that bar, that's just showing the repeating 6. And then I went, what did I do next? I wanted to take it to the exponent, so I said exponent. So I set my key. And then I was really lazy. I used bracket 1 divided by 20 equals divided by 20. And then I closed my bracket and boom, I got that answer. Now, if that's kind of weird, okay, it is kind of weird, but if that's too much, you could also go at some point, go 1 divided by 20 and you get 0.05. So you could do this and you could go caret and then just go 0. Oops, you don't even need the brackets then. All right, start again. 3. And then we do the caret. And then we go 0.05. And then you'll get your answer. Okay, and then I just subtracted 1 on both sides because that makes this disappear. And then it was times 4 because it was quarterly. So this is the interest per quarter as a decimal. So that adjusted for that. And the 100, that was adjusting, changing it back to a percent, not a decimal anymore. All right. I know. But you're not going to get a whole bunch of them on your exam. It's good practice. The more you practice, the easier they're going to become. I would like to have $1 million when I retire in 25 years. How much do I need to invest now? We got 7.5% semi-annually. Let's see. A, P, I, N. So $1 million. And I don't know my principal this time, but I know my interest. 7.5 divided by 100. Divided by 2 because it's semi-annually. And N is 25 years times 2. That's going to give me 50. 7.5 divided by 100 divided by 2. 0.0375. All right, formula time. A is equal to P 1 plus I N. $1 million. Make sure you get all the zeros. How much do I need now? 1 plus 0.0375 to the 50. Oh, sorry. Let's put those together. 1 million. Okay, so we did that. Now let's deal with that. $1.0375 to the power of 50. 6.3009. All right, now remember, 2 choices at this point. easy one. I'll do the easy one. 0.93813. I just wrote it all out. So then I'm going to divide this side by 6.309. Oh, see, I did it again. And you divide this side by 6.30093. So those are going to cancel, and away we go. So 1,000,003,456 divided by, ooh, can I use that? Haha, I think I have an answer key on my button. That should have brought that back up. And it did. So 158,706.5, and I'm going to round 1 is equal to P. So if you have an answer key on your calculator, ooh, can't see that right down there, that will bring back the last answer you used. Pretty cool. I want to do it completely right. 1, 2, 3, 4, 5, 6 divided by 6.300938913, and there we go. Get the same exact answer. Okay, you also could have used this answer, use the x to the minus 1 key. Anyway, you'll get used to keying and you'll figure out what makes you happiest. And that's in dollars, and I gotta circle that. Oh. How much would I need to invest if I had thought of this 30 years ago? Okay, so if I, okay. So, I'm going to have 55 years this time. Okay, for it to mature, my interest is still going to be the same up there. It's still going to be semi-annually. So let's see what a difference it makes. A, P, I, N. 55 years. And I am doing it semi-annually, so that's times 2. So it's going to be 110. And the interest is going to be exactly the same. 7.5 divided by 100 divided by 2 is equal to 0.0375. I still want $1 million. Okay, and principal is what I'm looking for. Now would be a great time. You know what? Pause the video. We just did one question about that was almost basically exactly the same, which is change some numbers. So go through it on your own. You have to learn to do these on your own. But you don't know. 1 plus I. Whoopsies. No. Too many variables. Remember that one variable at this point per equation. So I must know my interest. Oops. 0.0375 and to 110. 1 million. $1.0375 to 110. Oh, goodness, look at that. Million. Oh, I lost a 0 there. And it is 57.37089.067. And we're going to divide that. And I'm just going to be lazy and do that. All right, it's the same number. So, 1 million divided by 57.37089.067. And that's going to give me 17,430.4. So if 30 years ago, okay, so 30 years ago, just graduating university, if I'd been able to randomly store away $17,000 at a lovely investment of 7.5%, 25 years from now, I'd have make up the questions, live in the fantasy. Okay, so there we go. The point of this is, if you are able, the sooner that you can put money away and leave it, the better. To have some pension or some kind of savings when you get older. All right. Last ones. I have $2,500 and would like it to grow to $12,000 in 5 years. What interest rate will make this happen if compounded monthly? Suppose I left the money as described in part A. How long would it take to grow to that? Okay. I'm so glad I put in this question and left myself almost no room to do it. So it's going to get squishy, guys. Let's put that over there. As you can see. Okay. So we have got 5 years and we've got some money. So let's see. I'll do the years first. 5 years. And compounded monthly times 12 gives me 60. I'm looking for my interest rate. Oops, I already have that. So as a reminder, whatever it is, maybe divide by 100, divided by 12. And I'm starting out with 2,500 and going to 12,000. That seems like I'm going to need a pretty high interest rate because, you know, that's a big change there. A is equal to P, 1 plus I, N. So 12,000 is equal to 2,500. Oopsies, not 25,000. That's a real common mistake in finance. And it'd be terrible if I was in business. Just accidentally losing zeros here and there. 1 plus I to the 60th. So we want to get to the I, so we got to get rid of that 2,500. So let's divide by that. So 12,000 divided by 2,500 is 4.8. So 4.8 is equal to, this disappears, I, oopsies, 1 plus I, the 60th. Okay, now we got to do the funky exponent thing. 1 divided by 60. 1 over 60. Remember? I mean, I'm showing you the tricks. I've been told once you get into BA, if you're going into business, they have nice calculators and you don't have to do all this longhand, but it makes you a better mathematician. But I could see if I was doing it all day long, I certainly wouldn't want to do it this way. Anyway, I'm digressing more than a little. Let's try and make it easy. If I go 1 divided by 60, see how it's like a repeating decimal, weird thing? So I'm going to do this. I'm going to cheat a little bit. I'm going to write my key punch. So I'm going to go 4.8. So 4.8, let's clear everything here. 4.8, and then I want to do that to a power. So I press my power button, right, the caret key. And then I'm going to use a bracket because I want the exact value of 1 divided by 60, not the rounded off one that I'm going to get by only punching in some numbers. 1, so 1 divide by 60. Oopsies. Let's go back. Let's start over. 4.8 caret bracket 1 divided by 60. Close my bracket. And then equals. So it's going to be 1.02648834 is equal to 1 plus I. Yeah, I'm very curious here. When we did 1 divided by 60, I got 0.016 repeating. So what happens if I go 4.8 caret 0.016 and just hit a stupid amount of sixes? 64. Okay, I got the same answer either way. So it's up to you, whatever works for you. Okay. Now I'm going to subtract 1 here, subtract 1 there, because I want to get rid of the 1, so I have just the I, so minus 1. So 0.2, whoopsies, I lost a 0 there. 0.02648834 is equal to I, but that is per month and it's a decimal, so we need to adjust. So we're going to go times 12 and times 100. So that's why I write that over there. It just reminds me that the answer I got with the sucker is basically right here. So if I want to go back to have interest per year as a percent, I need to adjust. So times 12 times 100. That's going to be too much. I went times 1,000, so that moves my decimal. So it's 31.7. I don't want to retype it in. So I, please. Okay, so one more time. I screwed up, put an extra 0 there. That means my decimal place was 1 too far. Okay. So suppose I left, oh, never mind. Okay, there's my interest rate. Suppose I left the money in the account as described in part A. How long would it take for the money to grow? I really didn't leave myself enough room here. All right. So let's figure this all out. So A, P, I, N. So the amount at the end is 15,000. And we want to know how long would it take for this amount to, okay, I'm going to be honest. The question, the wording isn't that great. I'm taking it as I'm at 12,000 now, and I'm getting to 15. Around about 15,000. That's how I'm reading the question. I'm hoping that's what I'm supposed to do. As otherwise, I'll have to reshoot the video, or at least, yeah, let you know it didn't work. So I'm going to put the 12,000 there. Okay, stop talking. 12,000 here. Right? That's how I read the question. So you left the money, you had the 12,000 there with that. So interest is this per year, but we would have taken that number and divided it by 12 and divided by 100. So this is actually, nope, do it right. 31.7 divided by 100 divided by 12. Zero point 0.26417. I'm going to say that's enough decimal places. All right, which is, you know, basically what was here. I did some rounding there too. Okay, and n, we don't know. I will include this in the answer key. So n is equal to the log of a over p divided by the log of 1 plus I, like that. So n, now R8 is, okay, so it's log 15,000 over 12,000 over the log 1 plus 0.026417. 15,000 divided by 12,000. Log 1.25 over log 1.02647. Oopsies. Again, log 1.25 divided by log 1.02647. Okay, 8.558. Now, something went very wrong there, my people. So I'm going to stop the video, and then I'm going to figure out the question, and then I'm going to have a part 2 of this video. Thanks. Sorry about that.